Hello guys, today we will continue our smoking drinking classification problem. I'm really sorry for the absence because I got dengue, so that's why I am absent for so many days. I don't upload any video. So what we are doing, we are working on this smoking drinking classification problem. In this, we have done our EDA part. We are doing some visualization. Today we have to do this urine problem. Continue with this urine problem, and then we do our variable separation, you can say, and then train our model. So I checked so many algorithms, and I got maximum, you can say, accuracy, or you can say maximum accuracy score in using this gradient boosting algorithm. So we will continue with this, you can say, model. So first of all, let me run my notebook from start, and then we will continue with our visualization. Now we are going for hearing uh, site science department basics. Okay, so now it's time to look for urine protein presence by age group. Yes, we have to start from here. Okay, so what it has done, so this cell is running. After this we will work on our urine protein. Let's get it from time. So let's wait. Get our scatter plot here. Cool. Line plot of hemoglobin over age. Okay, we get a nice visualization. Now it's time to create line plot. So let me first check what's inside our urine column. It's giving me the it is in 17th, 18th, 14th. It is of float 64. So here you can see it is a 1. Is it giving value in 0 and 1 or giving float value? We have to check this. I'm sorry for my slow processor. I don't know why it's taking so much time. Yes. So now we can do. I think we are using here bar plot. Okay. So let me do this. Create bar with my x value as df of 40 using 41. Or we can do x level as age. Okay. So we can find our y value as df of you can say using 14. Using 14. And let me copy the title and let's see what it will give us. It will give us a desired value or not. I don't know why my physical development is so slow. Just wait. Let us see. So after that we have to do our cholesterol composition components over age plot. Okay. Then we have to plot our viral plot. And then okay, correlation variables. It can be possible problems or work that we check. What's the shape of our data size? So it is quite high, huge. That's why taking so much time. It's taking around 3.5 minutes. Oh my god. Till then we can trim this. So what do we have? So they have created age bin, and then you can say label. This we can do using let me check the range of age. So our age distribution is from 20 to around we can say 85 or 90. So till this happen, we can do one thing. Now we will try to create our bar graph using a age as our bracket, or you can say we will create, you can say, age group for this. We will age means, and here from age 50 we will do till this, and you can say 90, 70, 80 and 90, and then let me include the same for labels, age labels 22, 29. Here it will be from 42, or you can say 42, 49, then from 52, 59, then from 62, 69, then 70 to 79 and 80 to 89. So now we will create a new column in our data frame as df of age group, in which age group our you can say uh, age is lying. So it will we will use using pd dot cut from this. Our column name is age. It is age or age is like cross check. Here you can see it is age. Okay. So now we will give our beans. Beans is our here. By age beans. Okay. Now labels will be our age labels, and right is equal to false. What's this hyperparameter means? See. Right. Let me enable it. So what we have to search with pandas dot cut. Here it is right is equal to indicates whether bin include the rightmost edge of or not. So here our right will be false because uh, uh, 29 do not includes 30 value. That's why we have to type right is equal to false. Okay. Now we have to use group by method. Group df dot group by age group. Okay. What we have to group by? We have to group by Eugene 14. And now we will take the mean value. So now what we have to do, we have to plot our graph and give we have to give labels. Yes. I guess there is a problem somewhere in this. Let me restart my kernel. I don't know. Okay, we have to restart our kernel. Let's see our kernel restart. Here, let's our kernel is restarted. So we have to write this command again. again this will take so we have underscore. Okay, we can delete this and try to run this. Let's again this will take around 2 to 3 minutes. So we are in this. Again in this step it will take around 2 to 3 minutes. Till then it will continue, or we will continue with this crystal components. So here you can see first it created the age group. Okay, so we already done this part, so we do not need to do this. We can directly use group by, and then use stack plot. So let me do one thing, erase all this part. Age average cholesterol. Okay, so we have take our all three cholesterols and then plotted our strategy of noise. Okay, so we can now run this, and then we will do, you can say, do for oil and food. And that we will this. Okay, so create.boil and plot with our left. It will be, I guess. Okay, so this is for our left side and this is for right side. Show medium silicon control. Here we defined our x-sticks, that is 1, 2. Labels are site left and site right. Our y label will be site measurement. Site will be distribution of site. Okay. And we run this and run this. Let's see. So this is currently on this line plot. In my opinion, now we will get do not get any error. So we have created a violent plot here. Now we will do we will find correlation between variables. For that we will use df.core. Okay, and then create heat map using sms.heatmap. Okay, nice. So in correlation of y we will get the, you can say, we will get most correlated value with the list of correlation value with their indexes of how correlated with the our you can say dependent variable, or you can feature. First let it go. Then we created separated our independent variable. And yes, we have run this cell. We can also run this. Now we will separating our dependent and independent variables, checking if our data set is in balance or not. You can see our data set is balanced, so we do not have to do we do not need to do you can say balancing part. So we separated our training and testing data here using standard scaling. Instead of normalizing, I guess we are using standardization. Let me see. Standardization. Standard scalar. Oh. So in this our mean value is 0 and standard deviation is 1. Okay. Cool. Standardization. Let's see normalization. Standardization dividing the standard after. Okay. So it is standardization. Here I am you can say incorrect. It will be standardization, not normalization. We are doing standardization. Standardization. Oh, let me see. My spelling is correct to that. Yes, it is correct. Standardization. Yes, it is correct. Let me first we will fit it on xstring and then we will transform it on xtest. Okay. What happened? It is 23 number cell. Okay. I got my visualization. Here I got the could okay. So we have to you can say remove the now we have to drop the column name that is age group. I guess space it is age space. Let me cross check it. Uh, it is age group. We need to remove this group because for population we need all numeric variables, not all categorical common. Df dot drop. Our axis will be it is our column name and we do in place is equal to true. Okay. Okay. Yes, it is done. So now we can find correlation. Yes. Now we can create a heat map. Here we get nice visualization. Yes. Cool. Now what we can do, we need to check. Let's check what's the correlated. Uh, you can see height is 37% correlated with our you can say dependent variable sex. Let me check for BMI. So we calculated the BMI using height and weight column. So that's why we can drop this BMI column. So let me here with the age group, I want to drop which column I want to drop the BMI column also. BMI. Let's see. It will run or not. Yes, it will give me the you can say error because the age group is not defined in the access. But we can just for we will define again this with something will give the random value 1, and now try to drop this. It will run yes. Okay, now we will find the correlation. Correlation of y. Okay, now BMI is gone. Cool. uh, 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 we can discuss it with our domain expert, and we can remove or you can say we can do feature selection also. Here we can remove this urine protein column because it is around close to 0%, zero correlation. So this is not correlated with, if you can compare, this is not correlated with our you can say feature. So let me separate my x and y. Now check it. Now you split data. Now perform standardization. So we can remove this because we it is taking so much time. So we train using logistic regression, and before that we have to import from scikit-learn dot matrices. Import confusion matrix and our classification report. Here now we can run this also, please. Here we get our classification report with precision as 72% and recall as 72. With recall and 72% and F1 score is around our 73 and 72. Now we will be train it for using a random forest classifier and then gradient booster algorithm. We can drop this part because we have already done this. Let's see how much time it will take to train. And after that we will see which is our best performing model, and we will hypertune that module. That's it. Hmm, there is- So here in criteria we are using in, instead of entropy, because in entropy the calculations are it take you can say extra time, or you can say long time as compared to Guinea. Guinea is our fast, because in this we do not to calculate exponentially. In this our computation is very difficult. That we do. We can do Guinea entropy. Uh, so it is a logarithmic measure, and it is a linear measure. That's why uh, 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 entropy take extra time for computation as compared to Guinea, because it is difficult to calculate a logarithm as compared to linear function. That's why we have used Guinea for our you can say fast calculations. So from this our calculation time will be reduced, or you can say training time. So I don't know how much time it will take. I guess I have to shift my you can say menu from this to uh, I have to use Google Colab for fast computation. And next time we will use Google Colab for my PC bot heater. Let's see how much time it will take. Till then, we can let's check its hyperparameter table. Here we can give our low sense, loss or estimation. Okay, the look and estimation to be optimal function situation. Okay. For loss explanation, gradient boosting recovers the EDA boost. Okay, let's see. It is still running. So one hyperparameter, one parameter is our loss. It can be a log loss or exponential. In exponential, gradient boosting becomes the data boost algorithm. Okay. In learning rate shrinks the contribution of each tree by the learning rate. This is a trade-off between learning rate and an estimator. Value must range 0 to infinity. Okay. So an estimator the number of boosting stages to perform. Gradient boosting is fairly robust to overfitting, so a large number usually results in better performance. Okay, so here the value must range 1 to infinity. Then subsample the fraction samples to be used for fitting the individuals. These values. If smaller than 1, this results in stochastic gradient boosting, and then there is criteria. It is Friedman mean squared error and squared error. A function to measure the quality of a split. Spotted criteria are Friedman mean squared error, the improvement by Friedman. Let's so now our this training is has started. So in this we are getting the same around same results. That's, we can use minimum sample split, minimum sample leaves, minimum bit fraction leaves, and next step for and minimum impurity decreases. Okay. So there is language. So our main hyperparameters are one is loss, another is learning rate, and estimators and criteria. Okay. I guess this will again take time, and if we will try to hypertune it again, this will take a lot of time. So we can do one thing. For now, we will use the default model that is this one, and we will do not hypertune this, and now we will save this model, and we will head towards our you can say web development part. That is, we will create front end for this. We will create class cap for this model. Let me check this. Check this. Uh, Gradient boosting. Okay, I guess this is boosting technique. So we need normalization. Yes, we need normalization. We cannot skip the normalization part. This okay. Now let me import icon, import icon. Okay, saving the model and scale the scale. For that, I guess we have to use equal to term. Let me check. Yes, here it is. We have so our model name will be grad, and our scalar name will be scalar code k. So on scalar name is scalar. Let's see. So after saving the model, we will have to also go back. And let me have a query. We can copy this template level and paste this on smoking drinking classification data set. So here we start working on our, you can say that this is a template. We have to import spiller also. Spiller come dot load open model, not model, it will be scalar dot equal rp. Let's see, it is still telling. So here first I imported the Flask app, then I imported a request and then pickle. Here I initialize my app is equal to Flask underscore name, and then we have to give this if underscore name is equal to main, then it will run app dot run. Debug is equal to true. Debug is equal to true means if we change this in this app, then when it is running, it will show the changes also. So this will be our home. Okay. So this will render our index.html. Then we let me go to create index. First, let me remove this style. Style and try to. This is our smoking drinking classification. Classification. Let me copy this title and give this to this header here. Okay. Now what we have to do, we have to create the buttons part, not button part, we have to create our fields. So okay, our model is trained, so this model is giving us around 74% precision and 75% recall value, which is nice. So we will use this model. Let me save this. So here you get we get our model.pkl and scalar.pkl. Yes, what we can do, we can now save this logbook. So this part is done. Now we will work on our web app. You need to open the web. See what's our feature in the. So we have 24 columns. Let's see what's inside of it. Oh, no, so we need not to run the complete notebook again. We can see from here. So our first column will be sex and it will be of. It has two unique values, one is male and another is female. Okay, so for male we will map our value as 0. So we have to create a, you can see, gender column. Here you can see there is a gender column, and for male our value will be 0 and for female our value will be 1, and we have to remove this other option. Okay, now there is, I guess, also an age field also. Yes, there is an age field which is here. Okay, we can cut from here and okay, paste it here. Okay, now our it's time to for height. Again, the height will be centimeters. So height in centimeters. For height, type will be number, age will be ID will be height, and name will be. Now let's see, it will be weight. Now let's see, here it is given. We can use this. Okay, so our weight is in kg. Here in index to test here. We will copy this part. Instead of height, it will be wait, weight will be kg. Okay, so let's see also next parameter. It is side I side left. Let's see. Oh, so there is baseline also. So baseline is in float value. We can do one thing. We can copy BMI. Here it will be our instead of BMI. It will be waistline. So type will be text. Later in when we will request this label or you can say variable, we will convert this data type and convert this into float. When we will do it here, then we will use this as text. Now it is eyesight left. Let's see. It is of integer type or no, this is also of float type. Side left, side right. Here left, here right. Again, copy. Side left, side right. It will be left. And for side left, it will be side already side left. Name also be side left. Now we will do it for side right. Now side right. Okay, I guess now it's time for here left and right. Here left, here off. Let's see. Here in right. We can do this also. Here in left. Here Now we will go to SBP. Or we can do one thing. We can create field. In here left, we can create one option for 1 and 2 for abnormal. Yes. And let me go to the gentry point. In here in left 4 here. ID will be here left. Okay. And name will be also here left, and value for 1 it is normal, and for abnormal it will be 2. Okay, we can remove this, and here in left we can have here in right, here right, here right, here right. Now we move to our next parameter. Let's see. So our next parameter is SBP. SBP. It will be of a concept flow type. Let's see. Yes. SBP. Let me put this SBP. SBP. And name also will be SBP. Here we will give the what's SBP means. Oh, systolic blood pressure. Now we have to DBP. Okay, it will be DBP. dB+. Now we have to do it for BLDS. Let's see. BLD solver for float type. Okay. It is BLDS. 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 And it's it's BLDS or faster code equals. We can capitalize of BLD. Okay, cool. Now, so now we have to do it for our cholesterol levels. Let's see. It is total cholesterol HDL. So total cholesterol for total cholesterol. Let me copy this. And from here, let me copy the you can say field name. Total cholesterol. Nice. Now I have to copy this entire thing for other fields. 1, 2, and 3. HDL cholesterol. Here HDL cholesterol. Mm. And now we will do it for, I guess, LDL it is. Yes, it is LDL. Here it is LDL. Get rid of this. And here it will be LDL. Okay. Now the next variable is triglyceride. Let's see what's the major one. It is also Mg or DO. Okay, let's check what's our next parameter. So it is hemoglobin. Again, let me do one more thing. Hemoglobin is in, you can say, salt value, serum creatine also in, so all these are in salt values. Okay. This, let me check the unique value for this S and K. Let's see. Okay, this is for smoking history. Okay, and we have to check the unique values inside the protein column. I think we have to do this. Now let me check the unique value inside this column. In which column? In urine protein. Dot unique. So we have 1, 2, 3, 4, 5, and 6. Okay. Let's see. 4, 1, 2, 3, 4, 5, and 6. If it is negative, it is 1. It is plus less than 2. So plus 1. So now we are on triglycerides, right? Then hemoglobin. Copy from here. Hemoglobin. Okay. Now for urine protein. For urine protein, we can create a you can say option field, like as we do for our gender field. We will create around how many options? We need 1, 2, 6 unique values. So we have 2 unique, 1, 2, 3, and 4. So, it is urine protein. Protein in urine. And if it is negative, then if it is negative, plus or negative, then 4 plus 1, then plus 2, plus 3, plus 4. Okay. So our values are from around 4. Negative it is 1. So plus minus it is 2. Then 3, 4, 5, and 6. Nice. Now let's move towards the next derivative, serum creatinine. Again, this will be of 4 types. We have to put with this. Instead of hemoglobin, it is serum creatinine. Now, let me do this here. Okay, put that C like serum. So now it is astigmatic yeast. Let's see what's inside this. Okay, I think this is also of yes, this is of floor felder. And let me copy this. Now we have to calculate it for SG board list. And our next variable will be SGO ALT. Then gamma GTP. Now for SGO AST, we need to paste it here. Now for ALT, it will be ALT. We have to paste it here. No, this is AST. I forgot to copy. We have to select the entire and paste it here. Now gamma GTP. Now we can here now so I can remove this before to upload this. And now we have to do it for smoking state. For smoking state, we have 3 unique values. One is 1, 2, and 3. So again, we will create a button. Instead of gender, what to give our variable name is smoking state type city. Let me see. Smoking state. Smoking state. For never, it is 1. For never, it is 1. Option value will be 2, and for 2 it is used to smoke but quick. Used to smoke but quit. And for value is equal to 3, it is still smoke. Still smoke. Okay. So now we can remove all these fields. Now we can do one more thing. Let me copy this complete code and let me use ChatGPT for silent my code. Here.
100 रुपए का 2 किलो प्याज आएगा 2 का 3 किलो बढ़िया प्याज सूखा प्याज
I'm really sorry for the
आलू
disturbance.
2 रुपए दे 25 किलो भारी आलू 2 रुपए का 4 किलो भारी आलू दे रही हूँ
Let me do one thing. I want to just do
आलू ले लो भाई प्याज ले लो भाई लहसुन ले लो भाई कैसी लकड़ी कैसी आलू आलू प्याज नहीं कैसी आलू
add style to this HTML code. Here it is my diagram and see. So here we get our style. Let me copy this and we have to paste it below the title, I guess. Let's see. Yes, paste it. Let me save this index and now save this app and try to render this index.html. Let's see how it will look. Here you can see we get our options. And this is the age, height, weight, waistline, eyesight, nice, and for here left, right, okay, and then SPP. So we have to capitalize this. Okay, I guess this looking great. We have to centralize. We have to shift this button to center also. Shift submit button to center, or you can see align. We have to submit button for this. Now I have used table is equal to true, so if I will save this and reload this page, I will see, I can see the changes. So here you can see submit button is in now is in center. So I can remove this part also. And look, here let me remove for this thing, and also here I have to do capital B and capital T. Now let me reload this. Is it yes? It is correct now. Yes. Now what can we? So it is looking nice. Let me close my web app and so we have rendered our form. Now let's import these values from here. Okay. So our first value will be sex, and so this is a 0 and 1. First is gender, and uh, let me go instead of gender. Use sex here because here we have used sex. Sex. And we can use gender here, but so our first value is sex, and we have to request dot form. Okay. Now what we have to do for convert this integer, convert this age into integer. But here it is in also number. Let's see. Age is equal to integer into request dot form age. So here we already have this. Next variable is height. It is also an integer and weight is also an integer. Let's do the same thing for height, and this is for weight. Height Okay. Okay. So our next variable is waistline. Waistline eyesight. Okay. Waistline is equal to, so this is a float value, and request dot form waistline. Let me copy this pattern. This is for our eyesight one, left eyesight, right side, left side, right, and side left. I mean, this is for side right, and then it is here left, here right. Let's see here I did not manage here left and here right. Here left request dot form, here left, with this entire thing, paste it here for here right. So what's our next variable? SPP, DBP. Okay, now we have it. I guess all these are in float data type. Let's see. Yes, now all these are in float data type. Okay, wait. Okay, with this and here paste. Now we will do it for SBP. Let's see what's the name here. It is SBP. Okay. SBP. Now DBP. BLDS. Let's see. BLDS. And then it is total cholesterol. HDL cholesterol. Then LDL cholesterol. Triglyceride. 27. paste it here. And then for hemoglobin, okay. And after hemoglobin, we have urine protein. Let's check the ID. So urine protein urine request dot form urine protein. Serum creatinine. For urine protein testing for serum creatinine. Then for S what is S what is okay. So now for S what A ALT gamma GTP. So now it is for smoking status. Let me check. So we do not need to give this filter. Now we have imported our values. Then we have to import the scaling part, and I have a sample of like this. We can select store sales prediction. Here you can see we have scaled our data here. We have to import numbers. And now we have to scale our data for that and then save that variable in scale. So scale to transform np.array, and then we have to give this all variables. And then use reshape for reshaping this. Now you have to give all variables. First is sex. And here ordering is very important. We have to give the all variable in the same order as we give this in while we are trading this. Side left, side right, then here left, here right, SBP, DBP, BLDS. Let me see. Yes, BLDS. Then it is total cholesterol, HDL cholesterol, LDL cholesterol, triglyceride, then it will be hemoglobin. After that it will be urine protein, then it will be serum creatine, then SGOT, AST, then SGOT, ALT, then gamma GP, GTP, and at the last it is SNK, state type. Okay. So now we have transformed our data. Now we have to predict our value. So we will say this in our prediction variable model dot predict, and predict it for let me say we have to predict it for our scaled variable, and for it will be if our we defined an empty string that is output. If our prediction is 0, then it output will be false. If it prediction will be 1, then it will be true, and then it will redirect to this output. So if our output is true, then it will redirect to true.html. If our output is false, it will redirect to false.html. Now let me save this file and do one thing. Let's edit true and false.html. So here we will change the topic, or we can say title. And we can give our message here and added a home button here. So so if our value will be 1, then it is drinker. If it is 0, then it is he or she is not a drinker. or 4 false. He or she is not a drinker. He or she is a drinker. Now let me run this further. Let's see. Here we can see it is running. Now let's try to predict what we can do. Uh, we can predict it for our first data point. Let's see, for male. Let me do one. Male. Let me split the screen here. Age will be 35. Weight will be 170. Weight will be 75. Waistline will be 90. And then eyesight, that is what. Right is also 1. Hearing is normal. Right is also normal. Now SBP. SBP is our around 120. Then 80. 99. Total rest will be 93. After 193, it is 48. 126. 92. 17. And our protein in urine is, you can see, negative because it is 1. Okay. Then 1. It is 21, 35, and 40. And smoking history is, you can say, 1. 1 is for, I guess, never. Let me close it. Smoking history, 1 is for never, guess. Let's predict. We get an error. We give 23 features. So we forget to add 1 feature. Let's see which feature we forgot to add. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I'm really sorry, I forgot. I have to do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. So, what's our 24th feature? We have to open the notebook. Here we have 24 columns. Okay, so at last we have total impairment. total. So we created a new column here, total impairment. We need to drop this column also. Okay. So here, before finding the correlation, we have to add one more column, that is total impairment. Let me save here. So if we will now again run, we need to run this entire notebook. So it will take so much time, and I guess this is enough for today. I will, you can say, I will run this entire notebook again and try to run this app. Most probably it will run, and I do not get any error. So I think this is enough for today. Now let me do one thing. Let me close this app, open the terminal, and close my web app. So it is closed. Now I have to come again run this entire notebook. And thanks for watching.